Okay, so this is a typical university problem, okay. So here you have to obtain phase trajectory for the system. To be precise, you have to obtain phase trajectory for the error, the E. What is E in this figure? E is the error coming to this control system. E is equal to R minus C. And this E is going to an on-off switch. And this is called sine. The output of this nonlinear block is sine. If E is positive, the output will be plus M. If E is negative, the output will be minus M. And what is the relationship between U and C? U is equal to U into 1 by S square is equal to C, or S square U equal to C. Let us see the equations more formally. CS equal to US into 1 by S square, US equal to S square into CS. If you take L inverse, I'll get U of t is equal to C double dot. And E of t is equal to R of t minus C of t. And what is E dot t? E dot t is R dot t minus C dot t. And what is R dot t? R of t in the question is given as constant. Therefore, R dot is 0. Therefore, what is E dot t? E dot t is equal to minus C dot. And what will be E double dot? E double dot t is equal to minus C double dot t equal to minus U. So this, once you get this equation, I'm sure that those who attended my first session of today's class will be able to draw the phase trajectory. So practice many problems. Just hold on there. Previous slide. So E dot t is equal to minus U. I got this equation. And one more point which I want to tell you is once you reach here, you will be able to solve. E double dot t equal to minus U. Next slide. So there's a catch here. We don't want U, we want E. How is U and E related? U is equal to M into signum E. What is signum E? Is sine of E. M into sine of E. So let us define the state variables. X1 equal to E, X2 equal to E dot. Next slide. Therefore, what is X1 dot? X1 dot is equal to E dot, which is equal to X2. X2 dot equal to E double dot, which is equal to minus U. And minus U is what? Minus M sine E. Therefore, we got our favorite equations. X1 dot equal to X2, X2 dot is equal to minus M SGN X1. So this is our first step, isn't it, Aditya? We got equation for X1 dot and X2 dot. Am I right, Aditya?
Yes, sir.
So we got equation for X1 dot and X2 dot. Now, what I want is, what is the next step, Aditya?
X2 dot by X1 dot.
I want to find dx2 by dx1, which is x2 dot by x1 dot. Next slide. So dx2 by dx1 is dx2 by dt divided by dx1 by dt, which is equal to x2 dot by x1 dot. And dx2 by dt is equal to minus m sgn x1 by x2. So we got dx2 by dx1 is this. Now what is the next step, Aditya?
Cross multiply and integrate.
Cross multiply and integrate. Next slide. So I got x2 dx2 is equal to minus m sgn x1 dx1. And we have to integrate from with the limits x2 0 to x2, integral x2 0 to x2. X2 dx2 is equal to integral x1 0 to x1 minus m sine x1 dx. Please, can you read this equation 8 once more, because that is most important in our further progress. Aditya, please read this equation 8.
Integral from x2 of 0 to x2 into dx2 equal to integral over x1 of 0 to x1 minus m into signum function of x1 into dx.
Good. Now the point is, This is where a teacher is required, okay. How should I proceed from here? How will I integrate? How will I do this integration? This is the next crucial step. Anybody? Because linear there is no use, okay. I want you to think, and then if I tell you, that will make sense. How will I integrate a signum of x1? Anybody? Okay, I want to keep up my word, so I will explain. Next slide. We will do this integration as follows. We'll consider region. We'll do this problem in two ways. First, we'll consider the right half of the plane, phase plane. As you can see, the shaded portion. If x1 is greater than 0, what is signum of x1? Aditya, if x1 is greater than 0, what is sign of x1?
1.
1. So m sin of x1 equal to m. So the problem becomes very simple. Next slide. Recall the equation 8, integral x2 dx2 is equal to integral minus m signum of x1 dx1. We can, so this m signum of x1 will become what? Will become m. So what will be the new equation, Aditya? Just tell me. For region 1, what will be the equation? Equation 8 will become what?
Integral over the integral over x2 to x2 into x2 into dx2 equal to integral over x1 to x1 minus m dx.
Good.
Minus
dx1, okay. Minus m dx1, okay. There's a typo here, minus m. Because, so now things are very clear. Next slide. Next slide. Yes. So this is Aditya's equation. Integral x2 dx2 is equal to integral minus m dx1. And what is x2 dx2? It is x2 square by 2. And what is integral of minus m dx1? It is minus m x1. So if you apply limits, what will I get? x2 square minus x2 0 square. x2 is x2 of t, okay. x2 square minus x2 of 0 square by 2 is equal to minus m x1 plus m x1 0. Next slide. So we got the equation. This is the equation for parabola, isn't it? x2 square is equal to minus 2m x1 plus 2m x1 0 plus x2 square 0. What can you say about the last two terms in this equation, Aditya? Last two terms are constant. x1 0 is a constant, m is a constant. So this equation is of the form x2 square is equal to minus 2m x1 plus a constant. This is of the form y square is equal to 4ax, which is the equation for parabola. Next slide. Now let us look at region 2. For region 2, E is less than 0, that is x1 is less than 0. What is SGN x1? SGN x1 is minus 1. And substituting in 8, we get integral x2 dx2 is equal to integral m dx1. When you integrate and apply limits, you will get x2 square minus x2 zeros equal to m into x1 minus x1 0. If you take everything on the other side, cross multiply, you will get x2 square is equal to x2 square 0 plus 2m x1 minus 2m x1 0. And here it becomes x2 square plus 2m x1 plus constant. So this is again equation for parabola. Next slide. So these will be the trajectories. You look into your analytical geometry, which you have studied earlier, and realize that this is the shape. And this is explained in Nagarthan Gopal, and quite unlike of Nagarthan Gopal, there are some typos in Nagarthan Gopal. Please, so be careful about that. So I hope you understood this.